Hello. Okay. So welcome back once again. All right. So we are on section 8.2. That is last sample test for a population mean. All right. So now we want to test our hypothesis and want to use a step-by-step approach. But first of all, we have to know how to determine where our rejection region will be. So we call something the critical value approach. So we're going to use the critical value approach. So the critical value will help us determine the rejection region. All right. So first of all, in testing your population mean, all right, using the last sample, it implies that you are going to focus on the Z distribution or the standard normal distribution. So our first step is to write our null hypothesis. So this is the null hypothesis. This is how we write it. So your H naught and your HA. So this is the first step that you do. And since you're talking about the mean, we use the mu. And so we use the mu. So this can take these symbols greater equal to, less or equal to, greater or equal to. And this can also take this symbol not equal to, greater than, less than. Okay. So that is either you see this or you see H1. Okay. So all of them are the same. All right. And your symbol. So this is the first step. And then the second step that I'll tell you is to determine your Z test statistics. That is the standardized test statistics. And it is written as Z, which is equal to S bar minus mu all over sigma all over square root of n, or S bar minus mu all over S square root of n. We use S when we don't know what the sigma. Okay. Then the third thing that we do is to find our critical region. So in case we are using under the HA or the H1, this is the symbol that we see. So in case you see this symbol for the critical region, so critical region or the rejection region. Okay, so let me write a step-by-step approach. So if under the HA, so we determine the critical region based on the HA where we are going. So if under the HA, we are using mu with not equal to some value that we don't know. So then we either use this. So we either go this direction from minus infinity to minus Z alpha over 2 union. Then we pick from Z alpha over 2 to positive infinity. Okay, this is one of it. And in case the HA has less than some value K, then we are going to the left. So we focus only on this part. For this one, we don't divide the alpha by 2. We are only focused on one direction. And if you have the HA going to the right direction, then this will be our rejection region. So we pick from Z alpha to the positive infinity. Okay, so this is inclusive. Yeah, it's inclusive. Sorry. Okay, so this rejection region is determined under the alternate hypothesis, and that's how we write it. Okay, and our fourth step, what we do next is that now we compare Z and our rejection region and the rejection region. And make a decision. So we're going to do that. So in simple terms, if if your z is greater or equal to z alpha or z alpha over 2, reject h naught. And so this is I. If your z is less than z alpha or z alpha over 2, fail to reject h naught. All right. So with this in mind, we are good to go. With this in mind, we are good to go. All right. So all you need is what I've written here. These are the step by step, and I've explained each of them. Okay. So let's move forward. All right. So I've explained everything. The diagrams that you see, I've explained everything. Okay. So now we have to find our rejection region. This implies that we need the direction and we need alpha. That's all that we need for determining rejection. So that the rejection, when you are using the calculator only gives you the left part. It doesn't give you the right part. But in case you want the right part, then you have to take the negative of the left part to get the right part. That is it. Okay. So you hit on your calculator. So the alpha, since you are only on one direction, we don't divide the alpha by 2. So you hit your second and choose verse and choose the 3, the inverse norm. So the area given is your alpha, and that is 0.01. You're good to go. You don't do anything else. So hit enter and you're good. You get your rejection. So this is your z alpha, but it's an interval. So you pick from this to the negative infinity, and that gives us this value. Okay, based on the direction that you are going. We do the same for this, but this we have 2 directions. Okay, so we divide the alpha by 2 if you have 2 directions, one to the left and one to the right. Then you union them together using the same approach. So the calculator will give us the z alpha over 2 to be this. So divide your alpha by 2, so it will be 0.01 divided by 2. Okay, so this will be to the left and this will be to the right. Then you union them, use this symbol to combine them, and you're good to go. The same thing applies. So this, you are going to the right, but if you are using the calculator will give you to the left. But if you are going to the right, then use what? Negate the answer the calculator gives you and pick from that point to your positive what? Infinity, and you're good to go. Okay. All right, so the same thing applies to all, and I think it should be fine. So this is one example, and with this example, we're going to go through the step-by-step approach. So we write our hypothesis from this statement. Okay, so our mu is 1.88, but the manager believes that the actual mean is larger. So you have since it's larger, then larger means it's greater than. So it will fall under the HA, and this will be the claim. Okay, so we are going to what? To the right. Okay, so but after everything, we took a random sample of 45. So this will be our n. Our n is what? 45. Yields a mean of what? 2.09. So this will be the S bar that we want. Because step 2, we have to calculate the test status is Z. So if you write the formula down, you need your S bar, and you need mu, you need sigma, you need n. Either sigma or S, all of them works. And the sample standard deviation is 0.5. So that is the sample. So we are using what? S now. That is the sample standard deviation. So you have to perform the relevant test. So first is to write your hypothesis. You are good to go. Next, determine the value for this. That's Z. So you write the formula down. S bar is not 1.88. 1.88 is the population parameter that has been hypothesized. Now you take a sample. And out of this sample, you had a sample mean. So S bar is a sample mean, which is 2.09. And the mu is the population parameter. So you subtract that from the sample mean. Then you divide by the formula sigma all over square root of n. So sigma from the question is 0.5 and n is 45. If you put them into the formula, you get the answer to be what? To be this. Now, you determine your rejection region. So rejection region, you need the direction. from the HA and your alpha. So your alpha is the significance level, or the level of what? Significance, which is given to be 10%. So 0.1, since you are going to the right, it means that using your calculator, you hit 0.1, then you leave the rest, hit enter, but the calculator will give you the left. Take the negative aspect of it, and you get what? The right. So this will be your rejection region. This will be your rejection region. Now, what you do is that you compare your step 2 and step 3. So where does the Z value falls within the rejection region? We had Z to be what? The value for Z is 2.8174. And we are going to have 2.8174, which is within the rejection region. So we make a decision about H naught and then the claim. Okay, so what decision do we make? Okay, so since it falls here, okay, so the decision, since our Z value, okay, so if it falls there, it implies that it's greater than our Z alpha, okay, since Z is greater than the Z alpha, so if it is greater than, then we reject H naught. So if you go back, so anytime, in case you don't want to get confused about the region, normally you can also compare the Z and the Z alpha values. But if you are to determine the rejection region, it should be an interval. But in case you want to make a simple conclusion, you can compare the Z value and the Z alpha value, or Z alpha over 2 value that it gave. So you can compare them. So based on the statement that I make here, I said that if Z is greater than Z alpha or Z alpha over 2, then we reject H naught. So your Z alpha over 2 or Z alpha is what you use your calculator to determine that value. That's your Z alpha or Z alpha over 2. Then you compare it with your Z test statistic. Okay. If that Z is greater than Z alpha, reject it. Okay. That is what we did. But if it is less than it, we fail to what? Reject it. So here we reject the null hypothesis. That is the conclusion that we make. All right. So we have similar examples for which we go through. So here we have a two-tail. Okay. So we do the left and we do the right. So the rejection region will be the union of the two. The rejection region will be the union of the two. So to the left. But if you are using your calculator, the calculator always gives you the left. But know that since the HA uses what? The not equal to, it will be the left and what? The right. So you do that and you get your rejection region, which will be the union of the two. Either of them will reject the null hypothesis. But before you do that, calculate your Z statistics. Now, let's see how we can use our calculator to do the Z test without going through the step, without going through writing the formula. So now you hit your calculator. So you hit on the stats, you click on the stats, you move your arrow to the test. You're going to see one Z test. You are good to go. Now you input your value. So mu naught will be the hypothesis, the mu value that you see there. So in our case, we had it to be 1.88. Okay, and our Z value is 0.5. And our S bar is what? 2.09. And our N that you had is 45. Now, which side are we using? You are using the right side. Okay. So you hit enter to choose what? The right side. Then you do calculate. So it's going to give you the Z value. You see the Z value? That is that. So after getting your Z value, you can then compare it with your what? Your Z alpha value. The Z alpha value, we use the inverse to get it. Okay. So after getting your Z value, then you can write the answer down and go back. So you hit your second, click on fast, choose what? The inverse norm. since we are at one direction and the alpha is 0.1, so we calculate our alpha, which is what, 0.1. That is what we hit 0.1. We are good to go. Don't do anything. Okay, but we are going to the right, so take the positive aspect of it, although this gives you the left, but take the positive aspect of it based on the direction of HA. So 1.28, and your Z is 2.81. So Z is greater than what? This value. And if you are going to the left, then maybe you might have your Z value to be negative, and the Z alpha or Z alpha over 2 is also negative. So in case you find it difficult working with negative, convert all of them to positive and do your comparison. Okay, sometimes the negative can be confusing. So convert everything to positive. If you have the answers to be negative, you can convert them to positive and do your comparison, because it will give you the same conclusion. That is that. What I'm saying is that if I have Z to equal to negative 2.18 and I have Z alpha to be negative 1.18, then I can convert them, all of them, to be what? Positive. So I'll assume them to be positive and do the comparison, and I'm good to go. All right, that is what I mean. So that is a calculator way of doing it. All right. Shall we move to 8.3 very soon?